Have you opened RStudio and been instantly overwhelmed by the different panels and not knowing what to do or where to start? Yeah, me too. As strength coaches and sports scientists, we're continually told to move away from hand-bombing our way through data analysis and visualizations in Excel, but no one really tells you how to get there or where to go. But that's where this video comes in. RStudio is the tool that can turn your CSV and Excel files into one-step automations and visualizations so that you can create reports that your teams will actually use in the future. So the goal for the end of this video is for you to be comfortable in RStudio, know how it works, and know the overall environment so that you can continue to level up and be a better sports scientist. So before we actually get into how to work with RStudio and learning the environment, there are a couple of back-end things that you should know first. So first of all, it's a free open source software. You just have to go online and download it. So I'll leave a link to that in the description below. Second of all, it's built for data science. We're not trying to be data scientists here. We're trying to improve athlete performance, but it is a data science software. So there are a ton of tools that come with it and functions that we can use, and you can basically do whatever you want in it. And really the best part about R is that you can create reproducible and consistent results by writing simple lines of code that are then run with one click. And your reports can run automatically in the background without you having to hand bomb anything. And that's really what separates RStudio from Excel or other softwares. It's build it once and forget it. And then you can run your reports forever or make minor adjustments as you need it. So when you open RStudio, you're met with these 4 panels, which are all distinct and have their own purposes, but work together to create this RStudio environment that you're going to live in. So the top left here is where you can write your code. It's called the source panel. This is where you're going to write and edit your scripts that can then be saved later to be reused or tweaked based on what you're trying to do at that given time. You can think about this as your main area that you're going to be working and writing out all your stuff. So it's be like where you write your main programs and deliver them to your athletes. The bottom left is what's called the console, and you can type code in here as well. So I can write x equals 5 and then write x again, and it'll tell me that it's 5. But things that are written in here aren't necessarily saved. They might end up in your global environment, but they're not saved to be reproduced next time. So this is kind of akin to writing on a whiteboard or coming up with a workout on the spot that's just written down for somebody, but they're not really using later on as well. The console executes things immediately, showing the output of the code immediately below it, and gives you a history of what you've done in the past, so you can scroll back through and see what you've been up to. The top right is the environment that you've created within RStudio. It shows everything currently loaded into your R session. In this case, we don't have anything loaded in yet, but we'll see some of that later. It will show you the data that you've loaded, the values, and your variables that you've created. In this case, we can see that x is equal to 5. So really, your global environment is a visual overview of everything that's going on or that you've saved into R so far in this session. So in the bottom right, we have our files area, and as the name suggests, it showcases the files that are available to us, and then we can search through to find some documents. We have our packages, which are basically the overarching functions that we're going to use in our code, which we'll go into a little bit later in the video. And we have this help option where you can type in different functions, and we can try to get an idea of how we're going to use it and get an understanding of the syntax that is associated with it. So once you understand what lives in each of the 4 main areas of RStudio, you have a better understanding of what you're going to do in which area, and it becomes a whole lot less intimidating to open RStudio and start working within it. So one of the things that kind of trips people up first is the difference between the scripts, which are up here, and the console, which is below, because you can write your code in each, but they have a little bit different functions depending on what you're trying to do. So if we start in the console, we've already set x is equal to 5, and that's a variable that I wrote in earlier, and it's now saved in the global environment of x equals 5. So this console allows me to then work with different variables. I can write 2 plus 2, that equals 4, nothing exciting. But if I go y equals 5, we have x and y equals 5. And then if we put z is equal to x plus y, we type in z, it's equal to 10. So we can start to play with things and see how maybe things might evolve. And we can go x times 3, that's equal to 15. So these are some of the things that you can do in the console that are kind of immediate steps of I write code, I press enter, and I get the result. But they're not necessarily things that are going to be replicated later on in code or in the next session that you're in. So it's like a whiteboard, great for quick notes, testing things out, but it's not really the main driver where you're going to be writing your code. So in the script area, this is where, as you're creating reports and working with large data sets, you're going to start writing your code and then be able to open up your script so that you can then run your code and create reports. So what I'm going to do is I'm just going to pull up what a report might look like so that we have an idea of, you know, what we're going to get to eventually without overwhelming ourselves, because this is a down the line type of thing. So as you can imagine, I wouldn't want to have to write all of this code over and over again. So this is code that I use to analyze raw isometric dynamometry data to summarize based off the testing sessions. So what you can see here is it's a repeatable thing that I can open and just run this code. So by that it means go from the start to the bottom and go through and analyze based on all of what I've written here. And this is an advanced level of code, but it kind of shows what is possible. Like, you wouldn't want to write this in your console and then have to rewrite it every time. So it's just a saved area that you can then work on and ideate and improve upon as you go. So I'm going to close this script because we're going to work back into our main basic script here. And one of the things that we need to do is we need to let R know what we're going to be working with as we're working in our code and doing our data analysis. So what we need to do is load in what are called packages, which are these overarching files, basically, or folders that within them have a series of different like functions or calls that you can create or call upon for R to do certain tasks within your data. And all of these packages center on one specific theme of activities or commands for RStudio to do. So you want to think of packages like specialty tools in the gym. Your barbell is just your base R, kind of like what we wrote down here below. Packages allow you to build upon that. So your packages add in your squat rack and your specialty machines and your bumper plates, which allow you to then go beyond just a super basic program, or in this case, a super basic execution of code. So what we're going to do is we're going to load in our first package. So if you haven't installed a package, and I'm assuming you haven't because this is a beginner video, what we're going to do is we're going to type in install tidyverse, install.packages tidyverse. So install packages is a function for R to execute, and then tidyverse in the quotations tells it which one it wants you to install. So we're going to click that, and it's going to go through a number of things down in the console. It's executing the downloading of tidyverse. Then, to have it in this session of R, we're going to type in library tidyverse. And then we're going to press on max, command, and return. And that's going to run our code. So that means that within the tidyverse package, there's a number of kind of sub packages that go along with it, and they're all written in here. So now we have these available to us. And this doesn't really mean a whole lot right now, but as we go into our code more, it'll start to become more relevant. So don't really worry about the packages, but one of the things that becomes really relevant is the tidyverse environment that we're going to be working in. So that's going to be one of the main components of this whole series of working within the tidyverse to create really good reports that are easy to follow, creative, and provide all of the information that you need for your sport. So with our sports science data, or any data that you're collecting, it's probably going to be in a CSV or an Excel format when it's exported out of your force plates or GPS monitoring units, or if you're just creating it yourself and hand bombing your results. So what we're going to do is we're going to load in our first Excel file into RStudio so we can get started with some data analysis and see what happens. So first, what we're going to do is we're going to make sure that we have the read Excel package loaded. So we're going to go library and then in brackets read Excel. And then I'm going to press command and return. Perfect. And then we're going to call it a jumps file. Jumps.file. And here I'm going to use the backwards arrow and a line, and that's just an indication of saying like the jump file equals this thing that's coming up next. And that's going to be saved as a variable here in a sec. So we're going to go read underscore Excel. And then what I'm going to do is I'm going to go on my computer and I'm going to go find this document. So for me, it's saved just on my desktop in a folder called jump files. And I'm going to copy the file as a path name. So once you've found your file, you're going to put in brackets and you're going to paste in your file. So here it's users, my name, the desktop, jump file. And this is basically telling RStudio exactly where to find the file and what it's called. Now, if you don't have a jump file or a file that you want to work with, specifically you're ready to go, or if you just want to follow along with this tutorial and the ones that are coming up following this, then I actually have this file that I'm about to use as of download available on my website. So that's going to be in the first link below in the comments. And if you follow that, you'll get this emailed to you, and then you can come back to this video and follow along with every step along the way. So here, I'm going to press Command and Enter. And what we're going to see in our global environment is this jumps file has now been created. I'm going to double click on that, and it's going to open here, and we're going to see what it is. So this file has athletes, date, and their jump height. There are a bunch of other metrics associated with it. And this is athletes across a number of time points. So we have 93 total jumps that we're going to be looking at. So congratulations, you've just loaded your first file into RStudio, and it took 4 lines of code, but you have it in there and you're ready to go. Okay, so we're going to start with a little win. Now that we've added our jumps file in here and loaded that, we want to do something with it, because why wouldn't we? So what we're going to do is we're going to create a summary report of all of the jumps that our athletes did over the course of the last season, and get an idea of what their jump height is, what their eccentric impulse is, what their asymmetries are in the eccentric and concentric phases of the jump, so we can get an idea of how to compare against each other and where people line up. So one of the nice things about R is that there are things that can help you write your code faster. So here, I'm going to use the function str down in the console and call upon the jumps file. And what that's going to do when I press enter is it's going to show me what all of the columns within the file are. And then when I'm writing my jump summary call and create that, I can actually just look down below and see what these columns are, rather than having to jump back and look at this file, go back, type it out, and then bounce back and forth. So this is just one of those things that you pick up over the years that makes your life a little bit easier. So here I'm saying I'm going to create this jumps summary table, and the file that I'm going to use for it is, or the data that I'm going to use for it is this jumps file. And then from there, it's just saying this little percentage arrow percentage is indicating that we're using this jumps file for the following. And then we're going to group by. So as you can see here, as you start typing out your function, RStudio looks at it and kind of guesses at what you're going to use next. So here we're going to use group by. It'll tell you why you use it and how to write the syntax of it to use it properly. So I'm going to go group by, and we're just going to group them by the name, because that's who we care about. So we're going to group them by athlete. Then we're going to say summarize. We're going to open our command, and we're going to say sessions equal the number of distinct dates that were tested. And then we're going to work through all of the variables that we're interested in this case. So we're going to look at mean jump height, across the season, and that's going to be equal to the mean, which is the function that we're calling or the command that we're asking them to do. And that's going to be the mean of the jump height max on each given day. We'll do the same thing for SD. So I'm creating the variable here, SD jump height, and then I'm telling RStudio to use a standard deviation. So SD is the function, jump height max. So we're looking at the standard deviation of the jump height maxes of the people over the course of the year. And we're just going to repeat this process, which is a little bit tedious, but will save us time in the long run because then it's already created and saved and we don't have to do it by hand again. So next we're going to do mean relative eccentric impulse, and just going to continue repeating the process here. Copy and paste because that's going to be a little bit faster. Oh, that was the wrong one to paste in. Whoopsies. Relative net eccentric impulse. And then we're going to do the same for our eccentric asymmetry index. And our concentric one too. And what you can see too is RStudio will pick up that you're using this jumps file and it'll start telling you what the variables are that are available to you as you start typing them out. So that can save you some time as well. And SD con AI, what's SE con AI mean? Now that we have this jump summary all written out and coded, we're going to press Command and Enter. And what we're going to see is it show up in this global environment. So we have our jumps file that we already had created, and now we have this jump summary. And what we can do is we can look at it, and this will give us an idea of where our athletes are at. So this is the first data analysis that we've done in RStudio. So what we can do, these are sortable column names in this table that we've created. So we can see that some people have jumped way more than others. So Maple T has jumped 22 times. We can see who has the highest average jump height. So Johnson does at 52 centimeters. And we can go across all of the different variables and go from there. And that's going to be how you can do this. In our future videos, we will look at how to put this into PDF reports, how to export it, how to create interactive dashboards that you can then utilize. But this is the first step in being able to, so these 10 lines of code allow us to create this jump summary table that then we can use to understand where athletes rank against each other, make decisions based off of their training or how we should change their training. And the nice thing is, if we save this, all we have to do is reload in a new file, maybe once they test again or for a different group, and we can get that same table format with this line of code without having to write any more code. And that's really the power of R. It's you write your code once, you can execute it 1,000,000 times, and it'll always show up no matter how many people, in this case, are on the testing session or testing report, how many times they've jumped, it always works. And that's really the power of RStudio: speed, reliability, and accuracy without having to spend hours doing it. So in the last few minutes, we've seen how RStudio operates, how it's laid out, how we can utilize it to analyze athlete testing data and get better understandings of how our athletes are doing. So remember, if you want to walk through this example with me in real time, the link to download this data file is in the comments below and in the description. So make sure that you sign up and get that emailed to you so that you can come back through and do this example. And then you'll be able to follow along with the examples coming up in future videos as well. So be sure to hit the subscribe button if you're interested in becoming a better sports scientists, data analysts, and have better results for your athletes. Thanks again for watching.